Welcome to lesson 11-11. This is the volume of similar solids. Before we begin this lesson, this is your final lesson for Unit 11. Woo! Make sure that your quiz from last week is finished. That was assigned, I believe, on Thursday and due on Friday. Make sure that's finished because you will be having a test this Wednesday, so it's a good review for your test. So the first thing we're going to look at is we want to figure out what it means for solids to be similar to each other. So it means that their sides are in proportion, their angles are congruent. And one of the things we want to figure out if there's a special relationship between these solids. And we sort of did something similar to this when we did our first similarity unit, when we looked at like the comparison between perimeter, side lengths, area, surface area, volume, all that stuff. So we sort of did something a little like this. So for our first question of our exploration, we want to find the ratio of the sides / altitude. So the altitude is basically like a side length in our three-dimensional figure. It's just very hard to visualize it when you don't have the object physically in front of you. So we simply just want to find the sides that match up. So I'm going to color code it. So my 6 should line up with my 8. My 9 should line up with my 12. And my altitude of 12 should line with my 16. So the first thing we're going to do is we're going to write out those ratios. So 6/8, 9/12, and 12/16. We want to see if they can simplify. So I can simplify a 6/8 by dividing the top and bottom, or my numerator and denominator, by 2. So this reduces to 3/4. Nine over 12 reduces to 3/4 as well. Divide by 3, divide by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. I can also reduce 12/16 by dividing my numerator and denominator by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. What do you notice about your answers? Yeah, they're all the same. So that's basically saying that my ratio for sides, regardless of what I'm going by, will be the same as long as I'm just performing a basic dilation. We learned what this is called in our dilations unit. This is just called a scale factor. We use the symbol or the variable k to represent a scale factor. Now we're going to examine the ratio of our bases. The ratio of our bases are going to be triangles because if you look, these are pyramids, and pyramids have a triangular base typically. We know our area formula for a triangle is base times height divided by 2. So I'm going to call this pyramid 1, and this will be pyramid 2. So area equals 6 times 9 divided by 2. Area equals 6 times 9 is 54, divided by 2, 27. Now I'm going to do the area for my second image. Area equals base times height divided by 2. You should be trying to find the area of the second pyramid, the base of the pyramid by yourself. Base times height over 2. Area equals 8 times 12 divided by 2. Here's the thing, that's some big numbers. So what I'm going to do is I'm actually just going to do 8 divided by 2, which is 4, and then 4 times 12, which is 48. So my area of the second pyramid space is 48. So now you're probably wondering, how do I find out the ratio? So here's what we do. We simply just do 27/48, and we reduce it. If you type that into your calculator, you should get 27 divided by 48. You should get 0.5625. But the thing is, we want that as a fraction, so we hit math, enter, enter, and we get 9/16. And when we did this type of lesson, when we did similarity weeks ago, before we closed schools, we looked back to our original ratio. My original ratio was a 3/4. How do I get a 9/16 from 3/4? Well, I do 3 times 3 and 4 times 4, which is basically squaring my 3/4 to get 9/16. So I'm now basically looking at area is units squared and perimeter is just units. So I'm squaring that ratio to get my original ratio to get my ratio of a unit squared. How do we measure volume? We measure volume in units cubed. So in a reality, my ratio should be now 3/4 cubed. But let's find our volumes of the figure just to practice. So we know the volume of a pyramid is 1/3 BH. This is for pyramid 1. Pyramid 1 area of the base we found before was, we found before was 27. So we're just going to substitute that in for B. So volume equals 1/3 times 27 times our altitude of 12, or our height of 12. We're now going to look at plug that into our calculator. So volume equals 1/3 times 27 times 12, which is 108. I'm now going to do the pure volume formula for our second pyramid. I would like you to try to do this one by yourself, so maybe pause the video. Volume equals 1/3 BH. We said the area of the base was 48. And our height, or our altitude, is 16. So we just type it in. You should be doing this by yourself and get volume equals 256. We're now going to make that ratio 108 over 256. We're going to simplify it. We should get 27 over 64. Which actually goes back to our original question of 3/4 cubed. Units cubed, units. That is always going to be the way the ratio works. Now here comes the theorem. If two solids have a scale factor of a to b, then the corresponding areas have a ratio of a squared to b squared, and corresponding volumes have a ratio of a cubed to b cubed. And the reasoning why is because we're basically looking at it in terms of units squared, and then units cubed for our volume. So we basically are going to be trying to figure out, are we traveling from the units to units squared, units to unit cubes, and it's all about doing a close read of the problem. Just a quick note, the term areas refer to any pair of corresponding areas in the similar solid, such as lateral area, base area, and surface area. In our course, we typically don't study lateral area or surface area. We typically just study basic base areas. But we know that areas, every single area is measured in units squared. So therefore, we are going to be able to work with those in problems. Let's go on to some practice. So the cones below are similar. What is the volume of the larger cone? So here's the issue. You can approach it two different ways. We know that our volume is just going to be based off of our scale factor. So the first thing I'm going to do is actually find the volume of my original cone. We know that the cone volume is 1/3 pi r squared. So my radius is 5. Ooh, forgot my height, sorry. So my volume is just going to be 5 squared is 25 times 12 divided by 3 is going to be 100 pi. I'm just going to leave it in terms of pi to make it easier for myself. And we know that volume is measured in units cubed. But here's the thing. I have information about my height and my volume now. So I can actually set a proportion. Height to volume. So my height was 12 over 18. And I want to find out what the volume is of my larger cone. So my larger cone would be my x, and my smaller cone would be the 100 pi. Here's the issue. Height is measured in units, and volume is measured in units cubed. So before we even do a little manipulation, what I'm going to do is actually reduce the ratio of my height. I can reduce 12 over 18 to 2/3. So I'm going to do some erasing. And the reason why I can reduce it is because 12 over 18 reduces to 2/3. Divide by a 6, divide by a 6. And now I want to make sure I'm on the same page. So I'm going to cube my units. So when I cube it, I get 2 cubed, which is 8. 3 cubed, which is 27. And then I get 100 pi over x. I cross multiply and I get 8x equals 2700 pi. And then I divide both sides by 8. So the volume of the larger cone is going to be 337.5 pi feet cubed. And that's how you find the volume of the larger cone. All right. Now what I'd like you to do is try to do the next example by yourself. So in this example, pyramid X is similar to pyramid Y. The surface area of pyramid X is 126, and the surface area of pyramid Y is 350. If the volume of pyramid X is 405 centimeters cubed, what is the volume of pyramid Y? So here's what we can do. It's going to be a little outside of the box, because it's really hard to travel from, say, units squared to units cubed, but I can always go back to my regular units. So for this example, I'm actually going to do a little outside thinking. I'm going to go from my area to my height. And then we're going to go from my height to my volume. So I'm basically going to be going from units squared to units cubed. It's very, very outside of the box. This is an SAT skill. So I know that my area is going to be 126 over 350. And I want to find out what the ratio is for my height. So here's what I'm going to do. Instead of squaring and getting x squared and y squared, that's too much work. What I'm going to do is actually take the square root of my unit squared to make it a units. Because the only way to get rid of a square is to get the square root. So I'm going to do some erasing. And I'm going to take the square root of 126 over 350. But here's the issue. If you look at 126 over 350, you're going to be like, oh, those aren't perfect squares, Mr. O'Sullivan. So what I want you to do is do 126 divided by 350 in your calculator. And then hit enter, enter. and you should get a nice fraction. You should get 9 over 25. Boom. That's a nice thing to work with. The square root of 9 over 25 is really just the square root of 9 over the square root of 25, which is equal to x over y. The square root of 9 is 3. The square root of 25 is 5. And then I have my x over y. Boom. That is my ratio. So now, if I want to find the volume of pyramid y, what I'll do is I'll set up my ratio of height to volume. So my height is 3 over 5. And I want to find the volume of pyramid y. So my proportion is, one second, is going to be now 405 over v. And I'm going to use v for volume because I want to find the volume of my new image. But here's the issue. I'm doing units to units cubed. So what I'm going to do is I'm actually going to cube my 3 over 5 to make this now units cubed. 3 cubed is 27. 5 cubed is 125. And that's equal to 405 over v. We now cross multiply and we solve. I get 27v equals 50,625. And now I divide both sides by 27. And I get v equals 1,875. So the volume of pyramid y is 1,875 centimeters cubed. So I understand this is very, very problem solving, but hey, that's the fun part of this course. So here's your next task. Make sure you write down one noticing, one question you might have, and make sure you attempt the independent practice. Today is Monday, so we have office hours. So if you want, one thing I would do is watch this video lesson before you come to office hours. That way, when we work on the independent practice, you sort of understand where we're going. If you have any questions, please email myself or Miss Kimmick. Tomorrow, you're working on a review sheet, and Wednesday, you have your test. Have a great, great day.